text on inspecting concrete and masonry dams has provided you with important information about these structures, including certain fundamental knowledge about concrete and masonry dams, their features, and deficiencies associated with them. From the text, you learn that concrete and masonry dams are susceptible to a number of problems, which include cracking, concrete deterioration, surface defects, displacement, leakage and seepage, and maintenance-related concerns. This presentation will introduce you to techniques and procedures for inspecting concrete and masonry dams, and for recognizing and responding to deficiencies during an inspection. Information will be presented on inspecting the crest, the downstream face, the abutments, and the area downstream from the toe, the interior of the dam, and the upstream face. The information in this video is organized differently than the text. Before viewing this presentation, you should have read all the units in the text. You may stop the video at any time you wish and review information in the text. Now let's begin with inspecting the crest. When inspecting the crest, remember to systematically walk its length. One technique for achieving thorough coverage is to walk across along one side of the crest. Then cross over. And walk along the other side. Walking the crest gives you the opportunity to inspect the crest closely. Walking the crest also gives you an opportunity to get an overall picture of the condition of other features of the dam. For example, from the crest you can view the upstream and downstream faces, the toe area, the abutments, and the area downstream from the dam. Signs of seepage downstream from the toe, concrete deficiencies on the faces of the dam near the crest, and other problems may be more apparent from this viewpoint than from ground level. As you walk the crest, look for concrete deficiencies such as cracks, surface deterioration, and displacement. The text provided detailed information on these deficiencies in Unit 2. Since some cracking in concrete structures is common, you're likely to find cracks as you walk the crest. The types of cracks that may be found on the crest, as well as elsewhere on the dam, include structural cracking, shrinkage cracking, thermal cracking, pattern cracking, and cracking associated with other types of concrete deterioration. Some of the cracks encountered when inspecting a dam are serious. Others are not. Be especially concerned if a crack has appeared since the previous inspection, if a crack has enlarged, or if there is displacement along the crack. Measure the length, width, and any displacement along the crack. Photograph it and record its location in your notes. Displacement is an especially important deficiency to watch for when inspecting the crest. There are two types of displacement: misalignment, which occurs when the entire structure or feature moves, and differential movement, which occurs when one part of the dam moves in relation to an adjacent part. Displacement can cause offsets at joints, damaging the embedded water stops and allowing leakage through the joints. Displacement can also cause structural cracking, thus endangering the dam itself. There are a number of techniques you can use to detect displacement. One technique when inspecting a dam with a straight axis is to sight along the crest, looking at the structure from several different perspectives. Sighting through binoculars foreshortens distances and often makes irregularities more evident. If binoculars are unavailable, use the telephoto lens on your camera. When sighting, select a linear feature, such as this parapet wall, to serve as a reference line along the crest. Then look along your reference line from several positions. First, sight along the crest directly above the linear feature. Next, move or lean to one side and sight along the feature. Then lean to the other side and again sight along the feature. Crane rails and handrails are two examples of other linear features that could be used to detect displacement along the crest. Finding displacement by sighting along the crest of an arch dam is difficult because of the curvature. So at arch dams, study the crest from high on an abutment if possible. Also, look carefully at joints for offsets. And look at the concrete around handrails and other embedded metalwork for cracking that indicates displacement may be occurring. There are a number of instruments that can be used to detect displacement. These include surveying equipment, inclinometers, tilt meters, and plumb lines. More information on these instruments can be found in the module entitled Instrumentation for Embankment and Concrete Dams. When you find that displacement has occurred, measure and record the amount of movement. Describe the direction of movement and photograph any visible evidence of movement. Compare your findings with previous reports before developing conclusions. Another problem you may encounter on the crest, as well as at other locations on the dam, is concrete deterioration. Types of deterioration include disintegration, spalling, pop-outs, pitting, and scaling. When reporting on concrete deterioration, be sure to include measurements, sketches, photographs, and an adequate description of the location. Now let's turn our attention to the downstream face. Because of the difficulty in viewing the downstream face of a concrete dam up close, it should be inspected first from a distance, through binoculars. When using binoculars to view the downstream face, develop a systematic scanning pattern to ensure that you observe the entire face. You can scan back and forth, or up and down the surface. In addition, scan the face of the dam from one location, such as the downstream area. Then move and scan from another location, such as one of the abutments. After you have scanned the downstream face of the dam from a distance, you may decide to make a closer inspection of certain areas of concern. You may be able to do this by walking along the abutment contacts and the toe. In some cases, where tailwater at the toe of the dam prevents access, it may be necessary to continue the examination from a boat. When this is the case, you should make arrangements for a boat in advance. If you noted areas of concern on the downstream face away from the contacts and toe, it might be necessary to arrange for closer inspection using a movable platform suspended from the crest of the dam. As with other features, the downstream face is susceptible to cracking, concrete deterioration, surface defects, and leakage. Let's look at each. Note any cracking that is new, or that is increasing in length, width, or displacement. If you have doubts about whether a crack is significant, check with an experienced inspector. Structural cracks are the most serious, since they indicate overstressing and could affect the structural integrity of the dam. These cracks are often wide, run at an angle to the major axis of the dam, change direction abruptly, and are associated with noticeable displacement. Be especially concerned if the structural crack is new, or if it has increased in size. Whatever the type of crack, if it could be significant, measure its length, width, and any displacement, and describe it fully in your report. In addition to the type of crack and its measurements, your description should include the direction of the crack, the depth if discernible, and any trends in direction or movement. Also, be sure to adequately describe the location of the crack, with reference to other features of the dam. A second deficiency to look for is concrete deterioration. In addition to problems such as disintegration, look for drummy concrete. Drummy concrete can be detected by tapping on the surface with a hammer. Note the hollow sound. Another condition to look for is efflorescence. Efflorescence is the formation of calcium deposits on the surface of the concrete as leakage evaporates. Efflorescence may cause cracks or joints to widen, leading to faster deterioration and increased leakage. However, in some cases, the deposits may seal the crack against additional leakage. Monitor efflorescence and document its progress. A third deficiency you might find on the downstream face is surface defects in the concrete. These include honeycombing, stratification, stains, and impact damage. Examine surface defects carefully and include a photograph and description in your report. In addition to cracking, concrete deterioration, and surface defects, look for indications that water is leaking through the dam. Leakage may appear as wetness on the face of the dam. Staining. Vegetation. And, of course, water running from joints and cracks. If leakage is occurring at a previously unreported location, estimate the amount of flow and record the location. If the leakage has been previously reported, compare the amount of leakage with the amounts recorded in previous reports. This part of the video covered deficiencies commonly found on the downstream face. These deficiencies are described in more detail in the text. Now let's discuss inspection of the downstream area and the abutments. These areas may first be observed from a distance, using binoculars. Then, if possible, on foot. When inspecting the area downstream from the toe, look for deficiencies such as seepage and depressions. Examining the abutments is also an important part of inspecting a concrete dam. Cracking, scarps, and bulges may indicate instability in the abutments. Also look for seepage or signs of seepage, such as lush vegetation. Or sinkholes. Now let's turn our attention to inspecting the interior of the dam. Concrete dams usually have galleries inside the dam. The galleries allow for the inspection of the interior and provide access to foundation drains, operating equipment, and instrumentation. These galleries should be well ventilated and well lit to ensure safe and adequate inspection. Many deficiencies found at other places in the dam will also be found in the interior. These include cracks, concrete deterioration, surface defects, and leakage. Leakage in the interior may occur through cracks and joints extending to the upstream face. Try to determine the rate of leakage and compare your data with previously reported rates for similar reservoir levels. Weirs may be placed in gallery gutters to measure leakage. However, remember that gutters collect flow from the form drains and the foundation drains as well. Also keep in mind that deficiencies found in the interior may indicate conditions on the upstream face that are below the surface of the reservoir. Another feature to check when inspecting the interior is the foundation drains. These drains help relieve uplift pressure beneath the dam. Check to see that the drains are not clogged with chemical deposits, either visually or by sounding and probing. A progressive decrease in the volume of water flowing through the gallery gutters may be one indication of clogged drains. Visually inspect the drains and determine the flow rates at gutter weirs. Compare the results with previous reports. Now let's turn our attention to inspecting the upstream face. In general, you will want to schedule your inspection when the reservoir level is high, so that you can see how the dam responds to maximum load conditions. However, a high reservoir level usually means that only a small part of the upstream face can be inspected. Sometimes inspection of the exposed areas of the dam may lead you to believe that the submerged portion of the upstream face should be looked at. In such cases, you can return when the reservoir level is down, if that occurs in the near future. If you suspect a problem that should be investigated immediately, you may wish to recommend the use of divers. Remember, it is important that you note in your report the level of the reservoir at the time of your inspection. One way to inspect the upstream face and upstream abutments is to use a boat. Look at the face and abutments from a distance and close up. Also, develop a system for inspecting the face that allows you to examine all of the exposed surface. If you examine the upstream face through binoculars, follow a systematic scanning pattern as you did with the downstream face. As you inspect the upstream face, look for the same deficiencies as those that can occur on the downstream face, except, of course, leakage. These include cracking, concrete deterioration, surface defects, and displacement. Inspect the face carefully and document the location and extent of any deficiencies. Conclusions about upstream face conditions must be based on the conditions found above the waterline, on descriptions in past reports of upstream face problems, and on the problems you observe when inspecting the interior, the downstream face, and the crest. This presentation on concrete and masonry dams has provided information on inspecting the crest, the downstream face, the abutments and the downstream area, the interior, and the upstream face. Dam safety inspection is an essential means of identifying deficiencies with the potential to adversely affect the safety of the dam, and provides an indication of a dam's present condition. Inspection techniques and deficiencies related to concrete and masonry dams are presented in more detail in the text. There is also additional information on types of dams, dam features, and maintenance concerns. You may wish to review the text at this time.